Let us now look at question 3. For question 3, we're supposed to show that there are two turning points on this curve, and we're supposed to find the nature of the turning point using the first derivative method. Now, first derivative method involves looking at the value of dy dx slightly after and before the stationary point. Now, in order to do the first part, to show that there are two turning points or stationary points are points where the gradient is equal to 0. So, we need to find dy dx, equate it to 0, and show that there are two possible answers for that. Now, let us do the differentiation. Differentiating x cubed gives us 3x squared. 1 over x can be written as x power negative 1. So, I'll bring the power down, power decrease by 1. So, this gives us the gradient function. So, at stationary point, dy dx is equal to 0. So, we can solve this equation equal to 0. Now, in order to solve this equation, because there's a fraction, I'm going to multiply the denominator throughout. So, I'm going to multiply x squared throughout to get rid of the fraction. Then we will be able to make x the subject and solve for x. X power 4 equals 1 over 3. So, to solve for x, I'll take the fourth root of 1/3 on both sides. Now, because the fourth root is an even root, just like your square root, so it's possible for the answer to be positive or negative of the fourth root. Therefore, there are two turning points to this equation. Next, we're going to look at how to find the nature of the turning points. So, using the first derivative method, so we'll present our answer using this table. So, we need to find the x value at the turning point and use a value slightly before and slightly after this point. So, let us look at the positive x value first. Now, the fourth root of 1/3 is about 0.76. So, you need to use a value slightly before and slightly after. You do not exactly have to add 0.1 to the x coordinate. So, if the x point is 0.76, I'm just going to use 0.7 and 0.8 as the values before and after. Now, I will need to substitute these values into dy dx and figure out whether they are positive or negative. So, when I substitute 0.7, I get a negative value. At the turning point, of course, gradient will be 0. At 0.8, I get a positive value. This will allow me to take a look at what the tangent looks like. So, negative tangent would look like this, horizontal, and then the positive tangent would look like this. So, this means the graph has a minimum point at x equals to fourth root of 1/3. So, at x equals to the positive fourth root, graph has a minimum point. Similarly, we do the same thing for the negative of the fourth root of 1/3. Now, again, because this value is about negative 0.76, I need to use a value slightly before, so this would be negative 0.8, and the value after would be negative 0.7. So be careful, these are negative values. So 0.7, negative 0.7 is before the stationary point. Sorry, negative 0.7 is after the stationary point, negative 0.8 is before. So that's why we go from left to right. Similarly, in our table, the numbers must increase from left to right. Now, we need to substitute these values into our dy dx. So, when dy dx is positive, my tangent is going upwards. Dy dx equals 0, it's horizontal. Dy dx less than 0, it's a sloping downwards tangent. So, you can see that this is the shape of the graph. Therefore, at x equals to the negative fourth root of 1/3, graph has a maximum point. Now let us go on to question 4. question 4, we are supposed to find the nature and the coordinates of the stationary point on this curve. Before we can find the nature, of course, we need to know what is the x value of the stationary point. Stationary point would be where dy dx is equal to 0. So this is the concept for this question. Find dy dx first. When you differentiate e power 3x, you will get e power 3x times 3. The 3 here is from the derivative of the power. Next, differentiating 6x gives us negative 6. Now, at stationary point, dy dx is equal to 0. So this whole thing would be equal to 0. And then from here, we solve for x. Now, e power 3x equals to 2. In order to find x, because x is in the power, in order to bring the power down, I'm going to ln both sides. Ln e, so I can bring the power down, but ln e is 1. So this means on the left hand side, I'm just left with 3x. So x equals to ln 2 over 3. So this is the x coordinate of the stationary point. You also need to go on to find the y coordinate of the stationary point, because the question said find the coordinates of the stationary point. Next, we are going to find the nature of the stationary point. Finding the nature of the stationary point, you can use either the first or the second derivative method. Now, in this question, because my dy dx is a simple equation, I only have one term with exponential and the other term is a constant term. If I were to differentiate this one more time to find the second derivative, it's not that difficult. Therefore, I'm going to use the second derivative method. Differentiating 3e power 3x. I will copy down the coefficient. E power 3x will still remain. Then I'll multiply by the derivative of the power. So I'll multiply by another 3. Minus 6, when you differentiate, is 0. So you'll be left with just 9e power 3x. So to determine the nature, we need to substitute the x value into the second derivative. When you substitute this into the second derivative, you will get 18. 18 is a positive value. This means the graph has a minimum point at this stationary point. Okay, because the question wants the coordinates, you will need to write down both the x and y coordinate here. Next, let us go on to question 5. For this question, the equation is given. We're supposed to find the stationary value of y and determine the stationary point. Now, the stationary value of y means, of course, the point where dy dx is equal to 0. When you solve dy dx equals to 0, you will get the x value. But this question is more interested in the y value. So after finding x, you need to substitute it into the equation to find the y value. So that's for the first part. And then for the second part, we need to find the nature of the stationary points. So let us find dy dx. Differentiating 3x gives us 3. Differentiating 5 cosine 2x, I will copy the coefficient. Differentiating cosine 2x will give us negative sine 2x. We will also need to differentiate the angle and multiply by that, so times 2. So dy dx is 3 minus 10 sine 2x. So at stationary point, this whole thing would be equal to 0, which gives us a trigonometric equation. So we will need to solve this equation by making sine 2x the subject. From here, we will be able to solve for x by finding the basic angle. Question has given us the range between 0 to pi. Remember to ensure your calculator is in radian mode. Now, sine ratio is positive, so we are looking at quadrants 1 and 2. So basic angle of 2x, you can key in sine inverse 3 over 10 in your calculator in radian mode. So this is the basic angle. Remember not to divide by 2 at this stage. Using the basic angle, find all the possible answers. So the first quadrant answer would just be the basic angle. For the second quadrant, it's pi minus basic angle. So this gives us the two possible values for 2x. Finally, you divide by 2 to find the value of x. Okay, next, using this value of x, you need to substitute to find the y value. Okay, so I will let you do this part on your own. Okay, remember when you do the substitution, use more than 3SF for the x value. Okay, this is to ensure that your y value is accurate. Okay, so this is the first part. I will let you do the finding y coordinate on your own. Now let us look at how to find the nature of the stationary point. Now for nature of stationary point, again you can use either the first derivative or second derivative method. I'm going to look at my dy dx. The first is just a constant, which when I differentiate it will just be 0. The second term is just a trigo function, which is fairly easy to differentiate. So I'm going to use the second derivative method. So I'm going to differentiate my dy dx. Differentiating 3 gives us 0. Differentiating negative 10 sine 2x. So the negative 10 will be the coefficient. I just copy that down. Differentiating sine 2x will give us 2 cosine 2x. So the second derivative is just negative 20 cosine 2x. So to find the nature of the stationary points, we will need to sub in the x values of the stationary point into the second derivative. So for x equals 0.152, the second derivative is negative. So I basically substitute this here and I got a negative value. Then you can conclude, therefore, at x equals to 0.152, y has a maximum point. If the second derivative is negative, it's a maximum point. Then you repeat the same thing for x equals to 1.42. Okay, so I will let you do this part on your own to come up with the conclusion.